Okay, section 4.5 just reinforces everything you've been doing this whole chapter, but it starts, introducing it to all the different functions you'll be looking at. So first, what is a transformation again? It's a change, right, to a figure or function. Usually, right, it's a shift, stretch, compression, or a reflection of the parent function. And this idea of the parent function is something we're going to address a little more thoroughly as we go along. So the main idea of these transformations, right? What we're going to do is take these words compress, flip, shift, or stretch and put it in here, because these tend to be the ones that students mess up on the most. Okay? So first off, when you move the graph up, down, left, or right, what are we doing? That is a shift. Okay? Now, what happens when we pull the graph away from the x-axis, right? So basically, what they're saying here is if I have my parent function here, and we pull it away from the x-axis, meaning every point is getting higher, faster, what is that? That is a stretch. Then when we shrink it, right, we make every point closer to the x-axis. We call that a compression. And then anytime you see the word reflect the graph over a line, what that means is we are flipping it over a line. Alright? So now let's look at this table. This is the important part. What you have to understand with these, when we get to the table, is x represents the input and f of x represents the output. So what happens if we shift, right, up? Right? If we shift up, what we are doing is we're adding a positive number to the entire function. So you're taking your output or your function and you're adding a number to it. When we shift down, right, we are subtracting a positive number from the entire function. So here, I'm subtracting k from the function. Now if I want to shift left, that's when we add a number to every input value. So if I look here, remember, in function notation, it's f of the input. So if x is our input, we're adding k to it, which is going to shift it left. When we shift it right, we are subtracting a number from every input. So here you'll see we are subtracting a number from the input. When we have a vertical stretch, right, you are multiplying the entire function by a number greater than 1 or less than -1, meaning basically the absolute value. So if this number is a whole number or greater than 1, right, what that means is this is going to get more narrow. When you have a vertical compression, right, meaning you are shrinking, you are multiplying the function by now they say a fraction, I'm going to say a proper fraction, right, where the numerator is less than the denominator. Okay, So the number you're multiplying here would be something like 1/2, 3/4, where your numerator is smaller than your denominator. Or it's a number between 0 and 1. And what this does is it makes it wider. If you want to flip over the x-axis, right, what you're basically doing is multiplying the function by -1, or just the negative. It doesn't have to be -1, just the negative. A flip over the y-axis, you are multiplying the input by a variable, or by -1. So if you look here, now we multiplied the input by -1. Now, these next few are, a lot of math texts don't go into this, but when we have a horizontal stretch, right, what we're doing is we're multiplying the input variable by a fraction. So this is when we're getting wider. If we have a horizontal compression, right, what we're doing is we're multiplying the input variable by a number greater than 1 or less than -1. Okay, so this is where we're basically multiplying the input value, not the function. Okay, so when we look down below, we have some examples here. So one thing we want to do is look to see what type of parent function it is. Now, this is a linear function. And the parent function for this is always f of x equals x. So if we were to graph this parent function, it'd be 0, 0, 1, 1, right? This is what your parent function would look like. So what did they do to this, right, function? Well, what they basically did is all the x values and y values flipped, right? So this was a flip over the x-axis or the y-axis. You can look at it both ways. So anytime we flip or reflect, what we're basically doing to this function is multiplying it by a negative. So the function, this function would be f of x equals -x. Okay, now the next one, this parent function is called an absolute value function. Okay, and what this looks like as a function is f of x equals the absolute value of x. So these absolute value bars, anytime you evaluate the inside, it makes it positive. So when I look at this, the parent function here would be a V shape. So 1, 1, 2, 2. Remember, the y value or output will always be positive. So this is what the parent function looks like. So what did we do to the parent function? We shifted this parent function right 3 units. And what that means is we are basically, if we're shifting right 3 units, we are subtracting from the input. So basically we're going to do f of x equals the absolute value of x minus 3. So we're subtracting 3 from the input. Okay, so just to let you know, when we talk about the parent functions, right? So we have a couple. One is a linear function. And when we graph a linear function, it's going to be the graph of a straight line. That's what the graph will look like. and here is the parent function itself. Then, a minute ago we talked about absolute value, right? That graph would be in the shape of a V, and the parent function would be the absolute value of x. Then we have quadratic, right? Now quadratic, that graph is a parabola, which is a U shape, not a V shape, and that is f of x equals x squared. Okay, and then the last one is exponential. And when we have an exponential function, that is, you have exponential growth, and then you have exponential decay, right? So when we look at these, right, all the things we do with the inputs and outputs all relate to the transformations themselves. So when we look at these, right, so here it says, answer the following questions, what you learned from the lesson. Write your responses in the space provided. So this section's on shifting a parent function up or down. And anytime we shift a parent function up or down, you are adding a number to the function. Okay? If you want to shift it down, you subtract a number from the function. So, if you shift a linear parent function, so right away you know the parent function is f of x equals x, up 6 units, what is the equation of your new function? Your new function g of x would be the parent function x, and you're going to add 6 to it. Now if you shift a quadratic parent function 10 units down 10 units, what is the new equation? Well, g of x is equal to the parent function's x squared, so to move it down 10, we're going to subtract 10 from that parent function. Now when you go left or right, okay, anytime you shift left or right, anytime we go left, we basically subtract from the input. And anytime we go right, we add to the input. Okay? So when I look at this, you know, f of x equals the absolute value of x, and we want to go left 4 units. So g of x is equal to, now left is we add to the input. So it would be, the input is x, we're going to add 4 to it, and that becomes our new function. Now, exponential is a little different. Remember, f of x is something to, or sorry, a number to the x power. If we want to shift this right, remember, our parent function is f of x equals 2 to the x power. So what we're going to do is say g of x equals, right 2 means we're subtracting from the input. So our exponent is x, that's our input, so we're going to subtract 2. Okay. Now, the next one, a vertical or a horizontal stretch, right? For a vertical stretch, right, you're going to multiply the function by a number greater than 1. When you do a horizontal stretch, right, you're going to multiply by a number between 0 and 1. So if you vertically stretch a linear parent function, f of x equals 8 by a factor of 8, what is the new equation? When it's a vertical stretch, you know you're going to multiply it. It's going to get taller faster, so you're going to multiply by 8x. If it was a horizontal stretch, right, you would multiply it by 1/8. So here, if you have a horizontal stretch, the parent function f of x equals x squared by a factor of 4, what is the equation? Remember, right, when we have a horizontal stretch, right, you're multiplying by the factor, so it would be 1 over 4x all squared. Okay, next one. You want to flip the parent function across the x or y axis. Now, if you flip the absolute value parent function, f of x equals the absolute value of x, across the x-axis, right, what would you do? Remember, anytime we flip or reflect it, we're multiplying the function by -1. So in this case, g of x would equal, you're basically reflecting that, so if it's a v, all I'm going to do is multiply that function by -1, so you get negative absolute value of x. Across the y-axis, really it's no different, right? G of x equals, multiply the function by x, and you would get negative x. So let's talk about the combinations one. You're doing a vertical compression by a factor of 2. Remember, a vertical compression is making it wider, so when we say a factor of 2, since it's a vertical compression, we're going to use 1/2. And if we're flipping over the x-axis, we know we're going to multiply by negative. So in this case, multiplying the function by 1/2 and flipping it is a negative, we're going to multiply the function absolute value of x by -1/2. The negative flips it, the 1/2 compresses it. Number 10, g of x equals, right? If we want to shift 3 units right, we're basically subtracting 7 from the input. Shift 3 units up, we're going to add 3 to the function. So right away here, we have subtract 7 from the input. This shifts it right. And then to go up 3, we would add 3.